Alright, here we go on today's adventure. We're in Strand 4 and we'll cover the 3 standards in this portion of our curriculum. And the standards are: we have define and list examples of trace evidence, collect and analyze various types of trace evidence, define and identify a variety of microbes, and use a compound microscope to identify microbes. So this is going to be tricky because this is one I had talked to science teachers at Viewmont, and I had talked to them about borrowing compound microscopes. And as it turns out, we're still at home, so we'll see what happens. Okay, so we're going to just get right into it. Okay, so starting here is the definition for trace evidence. So it's going to be fibers, hairs, and other microscopic evidence which relates to the commission of a crime. So commission, if you look at the root word, is commit a crime. So this is committing a crime. So I've included some trace materials here, but they can also be things like paint chips, body fluids, stains, powders, explosive residue, vegetative matter, so that could come from someone's boot or something, metal particles, torn paper. And with torn paper, a lot of times they'll be like, do we have a piece that fits? And they look at the likelihood that it will fit. If it fits, then they'll go, puzzle solved. So ashes, a match, linoleum, itching powder. I don't know where that would come into play. A spider, they've collected spiders, and grease. Okay, so those are all examples of trace evidence. Okay, it's important that the investigator wear appropriate personal protective equipment whenever they go into a crime scene, not only to protect themselves, because remember, if it's wet and it's not yours, we're not touching it, but also to ensure the safety of the crime scene and to not cross-contaminate. So if you're losing hair in a crime scene, they'll go ahead and collect it and analyze it, and now you are in the crime scene. So we don't want to cross-contaminate the scene. In your assignment today, you're going to list out all of the protective equipment that you think would fulfill both objectives, keeping you safe and keeping the crime scene free from cross-contamination. The professor that taught me, the one that was like, no joke, 50 years he had taught this, said they would actually vacuum up crime scenes after they had collected everything they could physically see, and even kind of going over it with a fine-tooth comb, they still would vacuum the crime scene, and then they would collect the vacuum bag and then take that back to the lab and analyze what they found in the vacuum bag. So they do actually get that in depth. When matching items, magnification obviously is a great tool because we can't always see how things go together, and fragments of things and little fibers aren't necessarily going to give us much information just from the naked eye. So we can fit things together, and also we can analyze. The next slide. Okay, so here you have the definition of a microbe, and I'm going to go through the types of microbes with you so you can kind of get an idea for what those are. So they used to have, if you remember the from biology, you probably had a biology class, they'll go through and say, I remember like this, dumb kids playing catch on freeways get smashed. So D is domain. So in this case, archaea is a domain of single-celled organisms. And it used to be that they were like, it's bacteria. That was kind of the umbrella term, was bacteria. But they were like, I don't know if archaea fits. It is a single-celled organism, but they are microorganisms that define the limits of life on Earth. So they're originally discovered and described in extreme environments. So think like the hot pots of Yellowstone. They were also in a diverse range of highly saline, so very high salty area, acidic, and anaerobic environments. So I don't know where you would find these in a crime scene, unless it seems to me like a hot pot in Yellowstone would be a great place to dump a body. I don't know if that's I don't know why you'd have archaea come into play. Fungi, so next little bullet point is fungi. It's often associated with food. So obviously mushrooms and truffles, a lot of those we can eat. Some of them we shouldn't. You should research before you eat those. Molds are fungi, though, that grow on food that goes bad. So sometimes when they go into a crime scene, they'll see like a bowl of cereal on the counter. And if that bowl of cereal has some mold on it, they can do some time tests to say, okay, this mold grew this much. So we know that it has to be like 2 weeks old or something like that. So they can give you kind of a timestamp for when they ate last. Okay, bacteria, or they used to call it eubacteria. EU bacteria is like true bacteria. So, fun fact, Vikes, if you continue in medicine or you continue in science, which I hope all of you do, because there's lots to do as an adult in any of those kind of science fields, but you'll likely take a microbiology class, and that was probably one of my favorite classes. Anatomy was by far, hands down, my favorite. Some of my sports medicine stuff, good fun times. But there's a microbiology class I took when I got my biology degree, and we would go in and analyze bacteria. So I keep shaking my mouse over it. So here, I'll shake my mouse on this. You can see there are different types of bacteria. So the professor would have us go into the lab and he'd give us swabs, and he's like, today I want you to just swab your hand, and let's go ahead and put that on a petri dish, let that ferment a little bit, and then we'll come back and see it the next time. Well, one of the times he had us swipe inside our nose, which we were like, okay, weirdo. And we did that. And then the next time we thought he was weird, he got weirder. He told us, he goes, I want you to go into the restroom and swab. You guessed it. He wanted us to swab our butts. Yeah. And I was like, all of us were like, what is this weirdo? But he wanted us to swab it and then put it on a petri dish. Let's see what grows. And as you can imagine, we've got like E. coli, all kinds of bacteria coming from that area. So we went and swabbed it, and he's like, and we'll have a competition to see who's dirtier, the boys or the girls. And so we came back and who do you think would be grosser, boys or girls? I'm going to let you think about that. I thought boys for sure, but it came back, it shocked us, because we were like, the boys' petri dishes were overgrown with bacteria. It was almost kind of fuzzy. It was gross. And the girls were pretty clean. There were little spots here and there. I was like, yeah, that's what I thought. That's what I thought it would be. But it turns out, then he gets deeper into the experiment, and he said, what did you actually do when you went in the bathroom? And when a boy is told to swab there, he'll go ham, get as much bacteria as he can get. But the girls, we are a little bit more like, we don't really want like how much bacteria is in our bodies known to people. So maybe some of us swabbed our arm or maybe our cheek or something like that. But the reason we didn't have as much bacteria is we didn't go ham with the little swab. But you will have some fun times actually swabbing different areas of your body if you take a microbiology class. So we would also have to, sometimes you'd put multiple types of bacteria on a slide. He wouldn't tell us what it is, and we'd have to go and stain the slide and pick out if they were rod-shaped or circles. So if it's something like streptococcus, which would be like strep throat, those will be little round bacterias. So, and then there are little rod-shaped ones that are sometimes called villi, or in this, bacilli. So, fun facts. Viruses, like this is a picture enlarged of the coronavirus that we're dealing with right now, are traceable. And since we've got this disease kind of rushing over our country right now we have the swab where you stick the thing up your nose and get some sample of the cells, and they put it on a slide, and they can analyze whether or not this is the virus. And eventually they'll be able to test our antibodies to see if we have had it, and maybe we didn't realize we've had it. We'll be able to see some evidence of that. So might be a good way to, if you were examining how a virus sweeps over a nation like today, that could be something that you could do with it. Protista are simple eukaryotic organisms, usually composed of a single cell or a colony of similar cells. Protists live in water, in moist terrestrial habitats, and as parasites and other symbionts in the body of multicellular eukaryotes. So I guess if you maybe committed, if the crime scene was by a pond or something, we would look for some protista. And then we have microbial mergers. So these are microorganisms which are expert in entering into mutually beneficial collaborative arrangements. Those are lots of big words. They extend some essential services to animals or humans or plants, and in turn they get protected space for stay and nutrients for growth. So you've probably heard of our microbial biome, that is our gut, essentially, and they said a lot of what your health is like, it can be traced back to your microbial biome in your gut. We have healthy bacteria in there that actually help us stay healthy. And in crime scene science, they're actually starting to go, well, we can actually, even the microbial mergers that maybe exist on our skin, we can start to analyze those, just like fingerprints and DNA, to decide if this is the criminal that we have. Okay, and then finally, you're going to have a couple of things to do today. One of them, this is a good unit, lends itself to some labs, and we're going to do the best we can for this because we're in such a weird situation. It's so weird. Okay, and this is the instrument we would play with in class to identify microbes, and we already had permission. I got permission from the science teachers. We were going to use them. But I'm going to have you watch a video on this. I'll kind of describe it from my experience with these because I've used them a lot. In the case of, let's say that we wanted to look at something like the swab I was talking about earlier. Maybe we take the swab from the nose and we put it on a petri dish. And what we would do next is we would take a sample of what was on the petri dish and swab it onto a little glass slide, and then we put a protective cover over the top of it. Well, actually we would dye it first, because if you don't dye it, you can't really see what's in there. So you would dye it, put the slide over the top, and then the stage, so here's the stage right here. You would set that little sample on the stage, but you would do it with the smallest eyepiece up and the stage all the way down, because you can make the mistake, and I've done it before, where you're trying to zoom in and you've got like the longest objective lens out and you can crack your sample. So you have to be super careful. You put the sample on, put it on the shortest one, and lower the stage as much as you can, and then you start to manipulate. You can see there's a coarse focus here, there's a fine focus here, which this is obviously not in any kind of focus. But then you've got lights, the illuminator, so you have a light behind it, and then you're looking through the eyepiece. So I'll have you watch a video on that so you can kind of watch it and see how they explain it. And then you will have an assignment today. It's kind of a field trip assignment, and it has to do with collecting soil. So I hope you have a fun time with it. Please don't go anywhere that would put you at risk for coronavirus, since we talked about it today. So use it as your, daily PE or whatever you're doing. When you walk the dog, everyone's out walking their dogs. I'm convinced that the dogs aren't responsible for this pandemic because they're happier than they've ever been. You guys just keep going to announcements. That's where everything will be. It has been for a while. Some of you are just finding it. Good job. I only had to email like 40 times. Good job. So we'll pick up with Strand 4 next time. Thanks.